we go. Typical question again. Fencing question. This one is not as realistic. The other one was pretty realistic. The money goes up as as you raise the price, then sales go down. This one is, I'm just going to go buy some fencing and make a good fence. Usually there's like property laws about, well, I bought 900 meters of fence. I'm going to go, so unless you have farmland and like a big acreage, you don't usually go buy the fencing and go home and go, well, I'm going to find the biggest area I can make. Because you got neighbors, laws, it's your property versus not your property. So this one's not as realistic unless you're talking about a farm, which is they like to do farms. They're like, but we're on a farm, we have lots of room, so we bought the fencing, now we want to find the best area we can make, right? So they bought 900 meters of fencing. So this one's like the number question. We know it's 900 meters of fence, so that's going to go here on the left. It's given. It's a steady. We're going to find the maximum area. This is the part we're going to do the vertex of. So the vertex of this, and we've got where this is given. Okay, so this is more like the number question where we have the two kind of columns. So let's do this. I'm going to draw it just so we can kind of picture what's happening. Doesn't say you have to draw it, but I'm going to do this. So it's going to fence, rectangular fencing. It's going to be divided into 3 sections. Okay, doesn't matter if they're even or not, really. It's just what they're trying to say is that it says parallel to one of the sides. That means all of these are X. It's not crooked, so it's not this, where I did fencing, but I cut it up like interesting. No. This is what they're saying. So when they say parallel, it means these are all X's. Okay, so not crooked, not crooked fences. They're going to be all nice rectangular shapes. Same X across. Okay, and then I'm going to do Y for the side. You can use length and width. I don't know. I just use X and Y. Length and width is totally fine. Okay, so the Y is this way, all the way across. You can do Y like that, but I'm just going to go across and do 1 Y. Okay, some people do Y across, but then at the end you have to do 3 Ys. So it'll work in other ways, but I like 1 Y when I can, and then these X's here. So I've got 1X, 2X, 3X, 4X's. Does that make sense? So these are all X, the same X. Whoops. Okay, so 4 X's and then the 2 Ys. Okay, so that's my given. I have to have that, and it has to equal 900. So that's the part where, like with the number question where I said that's given on the left side. I'm going to take that, and I'm going to find the maximum area. So this maximum area, this is the part that I'm going to find the vertex of. So whatever I'm trying to maximize or minimize is the vertex part. So rectangular field, 3 sections, one of the sides, 900. So I have to do a let statement. You have to do the let statement. I don't want to take off any marks for this. I will. I don't want to. So make sure you do. Even though there's a diagram, I still want you to say something. So let X represent the width of the field. So just a simple sentence. Let Y represent the length. I use these little tick marks, so you're allowed to use them with me. Okay, again, the diagram was optional, so I'll put that over here. Okay, optional there. I use this tick mark. The tick mark means the word right above. Represent the of field. Okay, you can do that with me if you want. You can use the words. It's up to you. So there, and Y is the length. Okay, so then we're going to add them. So this is the part that's given. So I have to use the 900 meters. That part is given. So I have to say 4 X's plus the 2Y equals 900. That is a certainty. I cannot get away from that. That is definitely going to happen. So that part there, I separate that. That's my given. But I'm going to find the vertex of the rest of it. Okay, so I'm going to find the vertex of the second part. Okay, so let's grab this part. So the vertex part I'm going to do, I want to maximize the area. So I'm going to do area equals. The area of the whole thing is X times Y. X times Y, length times width. You have to know your basic kind of area, perimeter formulas, right? Those ones I don't give you. If it's something weirdly shaped, I'll give you that. But rectangles, squares, circles, you should know. Okay? We don't really do circles, though. We're okay. So rectangles and squares. Cubes, stuff like that. Okay, so here, X, Y, rectangular prisms. Okay, so here, we're going to take this one, so same idea. I can't have, what did I say? We can't have so many variables. You can have an X and a Y, right? We're going to do, it's like an x and a y. We're trying to do the vertex. You can't have an a, x, and a y. There's too many. So we're going to get rid of the y on this side. So isolate. So we're going to take this guy here, bring the 2, oh no, I'll isolate the 4x. Okay, so I'll get the y by itself. So I'll isolate the y and move the 4x over. So this will be 2y equals 900 minus the 4x. Divide everything by 2. You can divide each one by 2 like that, and you're going to get y equals 450 minus 2x. Okay, we get that beautiful thing, and then we're going to take that and we're going to substitute it into this equation right here. So all the way up here. Okay? So we take this lovely thing, and now we're going to sub it. So we're going to go equals, x stays where it is, but y is now this. We're going to take that and grab it in a bracket. Grab it, 450 minus 2x. So grab that whole thing, put it in a bracket, and put it over there. We're all good. So now you just have to answer the question. The hard part is kind of figuring out that part. Expand this out. 450x minus 2x squared. Oh, again, you could have done it the other way where you take the roots and halfway, but you can also do the vertex. When we maximize, we want to do the vertex. So we're going to go negative 2x squared plus 450x. I like it that way because then I can read my A and my B. Right? Again, you don't have to show this, but that's what I'm thinking. Got my A and a B. And now I want to get my vertex. Right? So vertex x equals, and it's negative b over 2a. So negative 450 over 2 times negative 2. So this will be negative 450 over negative 4. Okay, and when we get there, so when you divide that, we're going to either get a fraction. This one, I'll let you go to decimal, because I think otherwise it just gets a little not so fun, because it's 112.5. Otherwise, you have to do a decimal in that one. So, yeah, which is 225 over 2. So a little bit. So let's go to decimal. So I'll let you go to decimals on this one. So we're going to get, it's going to get exactly 112.5. Okay, and usually in the question I'll say you can use decimals or something. Read the instructions too, right? So 112.5 versus the 225 over 2. Okay, so 112.5. All right, we're all good. Just answer the question. So what does the question say? Go back up. So we're good up to here. At the vertex. Okay. What is the maximum area that can be enclosed, and what dimensions will give this area? So I want you to find everything. Right? So we have to find area. Okay? And dimensions. So we also want to find dimensions. So over here, find dimensions. When I say dimensions, what does that mean? So from here, I can find everything. What's dimensions mean? X and Y, right? So we got to find X and Y. Dimensions is the length and the width. So we want to find the dimensions and we want to find the area. So you can do either. You can do one first and then find the other one. It's up to you. We have the area. So remember I talked about this. You have all 4 of these formulas for area. So you can go back to X, Y. If you do X, Y, you should go find the dimensions first. Or you can go here, or here, or here. All of these are equivalent forms of the area. Okay, so I'm going to go to the second bracket, then I'm going to find the dimensions, and then I can kind of check my answer. So this is when here, remember this is x, so x now equals 112.5, right? That's what we found here. So it's going to be 112.5 times 450 minus 2 times 112.5. So that's 112.5 times, and it's 450 minus 225. and it's 112.5 times 225, which gets me, big number, 25,312.5. Okay. If you want to find the dimensions, sorry, is that okay? If you want to find the dimensions, you can go over here where you're finding the y. Y is actually 450 minus 2x. But do you know what? You already found that over here, right? That's your y. Remember, we took this here and we subbed it in. So this bracket here is actually your y. So you found it already. So it's 225. So if you already see, you're like, oh, I already found this, you can just grab it from here. If you forget and do it again, it's not too much work, I think. 112.5. You're going to go, wait, I feel like I'm doing the same two numbers again. You are. So it's right there. So that's the same. Does that make sense? You're like, oh, yeah, I did grab it over here. I feel like I'm doing the same number. So if you see it, then you don't have to keep looking for it again. You can just say, oh, I already found it, and then give that answer from there. Also, if you found this one first, okay, if you found this one first, you could have said, but I know that my x is this, so can't I just multiply these two to get my area? Look, it's 112.5 times 225, which is this, right? So to get the area and the dimensions, you might be able to shortcut that a little bit and go, I already saw I got this, so you can go a little faster. If you don't, you just do the steps. It's not a big deal, right? Conclusion, please. Right? So don't lose any marks for not answering the question and also for not doing a conclusion. So therefore, the max area is, you can short form a word a little bit, but I don't want you to put equals on your answer, right? I want a sentence answer, not a equation, right? So max area is 25,312.5 meters squared. Don't forget your meters squared. Okay, I'm going to star that. Okay, you're doing so much work. The little half marks are a waste because you did so much work on all the hard part here. Okay, maximum area is that. With dimensions, okay, dimensions are going to be these two guys here, the x and the y. 112.5 meters by 225 meters. Okay? And now you're going to practice the shape question, the number question, and wait, what else? The price question. And then sometimes there's the diagram questions where like it's a soccer ball and stuff like that. So those kind of diagram or the descriptive questions. All right, that's it for 3-2. Any questions?
What are we doing?
Oh, sorry. Yeah, on the back, I was just summarizing what we figured out. So what we have found out now. So vertex form, yeah, so let's just summarize. So what have we got? We know vertex form is, and I'll answer your question. So y equals a x minus, I've used p and q. I know a lot of teachers also use h and k. It doesn't matter, right? That might use h and k. So p, q, h, k, there. Right? So from your vertex, if we have this, then what did we do? We would complete the square. So you could do complete the square, completing the square to get vertex form, right? So if you completed the square, you can get this beautiful vertex form. So we know that's called vertex form. So you can complete the square to get vertex form. From here, you know your vertex is PQ. And you can read your maximum and minimum off this easy. So therefore, max or min value is Q, right? Whatever the Y value is. So from here, okay, when X equals whatever the P value is here. Right, so that's okay. So you get the P and then the P value from your vertex. So you get all that information. If you have factored form, that would look like this. So maybe x minus a, I'll use a and b. Right, so you might have factored form, so we know what factored form is. If you have factored form, you can take these two roots, and you would say those are my roots, and you're going to say x equals a, and here x equals b. Does that make sense? Right, from the stuff we did before, x equals a, x equals b. And then you would find your vertex x by going a plus b divided by 2. Does that make sense? So you're allowed to do this. Again, I showed you that on that first example. So you can add the 2, divide by 2, and then sub, right, and then sub back for y. Right, so then you can get your x and your y from there, et cetera, et cetera. So that's factored form. Yep. Okay. So vertex form is this form. You usually complete the square to get that. Okay, we can get that from there and get all the information. Factored form, you take each one, add it, divide by 2, you get your x, your vertex x, and you get your y value. Okay. Then the last way that we have now as well, and right, and we're adding this one here, is what if I had, going up here, okay, standard form, which was that nice expanded form. Y equals ax squared plus bx plus c. So if you expanded it out, right, and you went, okay, I didn't complete the square, I don't have factored form, then we were still able to answer it, and we were able to get the vertex x by doing negative b over 2a. Right, so now we have 3 different ways to get to our vertex. We can still complete the square. You can use the factored form, add it, divide by 2. Right, so you can do this. You get your 2 roots, and then you add it, divide by 2. Here, I can take from here. We know that the a, right, a is that one. The b is this one, and plug those into here. Does that make sense? You take those from those values there, plug them in, and then sub back for the y value. Okay, so you have 3 different ways to get a vertex now. Okay, all of them are wonderful, right? So you can use any kind of interchangeably, and I won't make you use one way versus another. You choose. All right, now we're good. Any other questions? Good. Okay.